Hello all. Here another problem from the job sequencing, solving the job sequencing problem using the graphical method, where we have 2 jobs and 5 machines or 5 job sequences. So the problem what he has given is job 1 in the sequence A, B, C, D, E, the processing time given 3, 4, 2, 6, 2. For job 2, the sequence is B, C, A, D, E, and the processing time given 5, 4, 3, 2, 6. So this graphically how we have to solve and how we can calculate the total elapsed time using the graphical method. Let us see. Now, as it is a graphical method, so on the graph, first you have to take the scale. So when you are taking the scale, just calculate the total time for job 1 and total time for job 2 so that we can scale on the graph properly. So here if we observe on the x-axis I have taken the job 1 and on the y-axis I have taken the job 2. And here see the job A is taking processing time maybe 3 hours. So sequence job 1 A is taking 3 hours. So this 3 hours we have to represent in the graph. So starting from the 0 to 1 hour, 1 to 2 2 hours, 2 to 3 3 hours. So total job sequence A is taking 3 hours, B is taking 4 hours, and C is taking 2 hours, and D is taking 6 hours, and E is taking 2 hours. In the same way, here also in the job 2, B is taking 5 hours, that is 0 to 5. So 5 hours it is taking. C is taking 4 hours, and A is taking 3 hours, D is taking 2 hours, and E is taking 6 hours. So the scaling has to be done based on the job sequence. Okay, based on the job sequence. Now, as machine A in the job 1 is taking time 3 hours and job 2 machine A or sequence A is taking 3 hours. So let us take the point here. So here's machine A is taking 3 hours and job 2 is also taking 3 hours starting from 9 to 10, 10 to 11, 11 to 12. So here I am placing a point. So here I am placing a point from 12. So let's draw the, so you will get in the form of rectangle or squares. So I am drawing this. Okay. So this becomes machine A. So I am or machine A or sequence A. Machine A or sequence A. Okay, no problem. Second, B. B is taking processing time 4 hours. Job 2 is taking 5 hours. Job 2 is taking 5 hours, and from 3 to 3 to 0 to 1. So point here, from 3 it is taking, from 3 it is taking 4 hours, 1, 2, 3, 4. So up to 7. 1, 2, 3, 4. Okay. So 4 hours. And machine job 2, machine B is taking 5 hours processing time. So 0 to 5. So here it is 5. So let me draw this one. So on graph you will get perfectly as I am doing it manually. So few points may differ, but when you do it graphically it comes perfectly. So this can be considered as sequence B or machine B. Now see, job 1 is taking 2 hours. So here job 2 is taking 4 hours. So this one is taking 2 hours. So from 4, so here 1 point, so 1, 2. So this is 2 hours, and C is taking 4 hours. So from 5 to 9. So from 5 to 9. So this one we considered as C. Now job 1 D is taking 6 hours. So 6 hours from which point? From 9 to 6 hours. So here I am taking, this is the 9 and D up to 14. D up to 14. So I will just place, let me check. This is okay. D14 from where? From 12. So here I am making this one from 9 to 15, that is up to 15. So here I will take up to 15. From 12 to 15. So you have to be very careful when you are drawing on the graph. So the points you should not miss, because based on the connecting points only we will get the feasible solution. So this is considered as sequence D. So E is 2, the 15 to 16. So 15 to 16, 16 to 17. So where is E? Here it starts with the (15) to 17. So here I have connected, and up to 20. Let me check. So I have given this one. So E. Now see, we got sequence A, sequence B, sequence C, sequence D, and sequence E. So from the starting point, this 0 on the 45 degrees, so So 45 degrees, if we will get like this, so we have to draw a line 45 degrees, right? This one we have drawn, and here it is intersected. So when the intersections are there, again we will go with the vertical lines. So again vertical line, and again 45 degrees. So this point goes to here. So there is a point here, 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 and here. So from this 45 degrees will be So 45 degrees will be connected. So here again I am going with the horizontal because it is intersected. So vertical line, again here you have a point, here you have a point, and again 45 degrees, 45 degrees, so here I am taking it this to here it is intersected. So again vertical line and we are finishing with the horizontal line to the end to complete this. So here this is how whatever the processing time he has given for 2 jobs with the 5 sequences, graphically we have represented. Now the total elapsed time can be found by adding the processing time of job 1 and its idle time. So idle time always represented with the vertical line. So this is the idle time, and final idle time for this one will be like this. So from at x13, so here if we observe, here we have from 3 to 5 there is a vertical move. So here we can identify there is 2 units, and here 12 to 14, that is again here we have 2 units, and 19 to 20 there is 1 unit. Job idle time, job 1 idle time. So for the job 1 idle time will be 5 hours. So total time will be processing time plus idle time. So processing time is for job 1. So for job 1, processing time is 17 plus 2 plus 2 plus 1. So 2 plus 2 plus 1 will be 5. 17 plus 5 will be 22 hours. Many units hours. Okay. Now for job 2, processing time see for job 2, this one, here we have the processing time. So how much processing time here it is 2 hours, 15 to 16, 16 to 17. So here we have an horizontal line. Here if you observe, here we have an horizontal line which is finishing to that particular point. So this can be considered as idle time for job 2. So for job 2, processing time is how much? 20 plus idle time is 2. So this will be 22 hours. So total elapsed time will be 22 hours for job 1 and 22 hours for job 2. So this is how we can solve graphically the sequencing problem. Okay. Thank you.